Greetings, math fans. All right, so this is day 4, and we're talking about implicit differentiation. And basically, implicit differentiation it's a type of differentiation. And it's used to analyze functions that can't be put into the form y equals. Okay, because that's all the functions that we've done so far. It's always been y equals. I told you to take the derivative. You guys use the chain rule, use product rule, quotient rule, power rule. You've done a lot of different things, but it's always been y equals. All right, and so now I'm not going to give you an equation like that. In fact, if you guys would look into your book on page 157, there's a really nice function, which it's actually a function made up of 3 different functions. Looks kind of like this, if you don't have your book with you. Kind of like this and like this. That's a pretty bad sketch, but something like that. And it's made up of 3 different functions. You can even see what it looks like in the book, but it's like this function right here, and then there's another one up to here, and then there's another one over to here. All right, so it's actually a very complex fraction. In fact, the equation of this one is x cubed plus y cubed minus 9xy equals 0. And if I asked you guys to solve this using our old methods, you guys would cry, you'd drop the class, it would be really, really, really bad. All right, but now what we're going to do is we're going to actually, you don't have to solve for y. We're actually going to solve it implicitly, where you can leave it in any form and we can take the derivative. So let's talk a little bit about that. First of all, implicit differentiation is we're going to differentiate with respect to x, as we've always done. Okay, and this is important. So you have d by dx, we're differentiate with respect to x. And do you guys agree that I can write this just as we did substitution before with the chain rule? With u substitution, we have d by dy times dy dx, right? And here's our chain, here's our link, is the dy's. So that's why d by dx is equal to d by dy times dy dx. All right, so this is actually really important. We're going to be using this a ton here. All right, so let's start off with our first equation. X squared plus y squared equals 9. Okay, you guys should recognize what this is. Of course, it's a circle, center 0, 0, and radius of 3. And you know, normally, like back in the day when you guys would find the slope of the tangent, right, you would solve for y, then take the derivative, which you could do here, but the deal is with this problem is you're going to have plus and minus. So you actually have 2 different functions. It makes it messy when you're trying to come up with one function for the derivative. So what we're going to do is we're going to take the derivative implicitly, which means I'm going to do d by dx of that whole function. So I'm showing a lot of steps here. D by dx of x squared plus d by dx of y squared equals d by dx of 9. Well, the first one's really easy. D by dx of x squared is just 2x. All right, well, we can't take d by dx of y squared, but again, I'm going to write this on here. D by dx equals d by dy times dy dx. So what I can do is, I'm just going to show some steps here. It's going to be d by dy of y squared times dy dx. And then, of course, what's d by dx of 9? It's a constant, so it's 0. All right, so now let's show another step here. 2x plus, what's the derivative with respect to y? Well, it's just 2y. We still have our dy dx here, and that equals 0. So what I'm going to do now is I'm going to solve for dy dx. So I'm going to subtract 2x from both sides. So I get 2y dy dx equals negative 2x, and then divide both sides by 2y. So you get dy dx is equal to negative x over y. So there is our derivative, math fans. All right, negative x over y. And just to kind of show it's pretty easy, right? You guys, let me sketch this real quickly. I'm going to sketch our original equation, which is a circle, center of 0. And there, that's a rough sketch of that. And if I ask you guys to find the slope of the tangent at 0, comma 3, right? It's got to be on that circle. Well, that's up here. And so what should that slope be? It should be 0. Well, of course, if we plug it back in into negative x over y, our slope here, we get negative 0 over 3, which is 0. So there we go. Our slope is 0. And what happens if we choose a point like 3, comma 0? Well, that's going to be a vertical line. And, of course, that's going to be then negative 3 over 0, which, as you already know, it's undefined. All right, so it's kind of cool. Does a nice job with finding our derivative. So let's actually write down a couple of steps here. Okay, they're going to help you out. So these are steps for implicit differentiation. First step is you're going to take d by dx of both sides of the equation. And again, remember, d by dx is equal to d by dy times dy dx. Okay, the second step is you're going to collect the terms with dy dx, right? After we actually take the derivative and we have our dy dx left over, you're going to collect those on one side of the equation. All right, and third step, and this is really algebra now, you're just going to factor out the dy dx. And of course, the fourth step then is just solve. So when you factor out, then you're going to divide and you're going to solve for dy dx. Okay? It's really pretty easy. You just have to be really, really careful. Okay, so let's do our first example here. You got x to the fifth y squared plus x cubed y to the fourth equals negative 20. So I'm going to do d by dx of that. Take the derivative with respect to x. So again, I'm going to kind of show a lot of steps here, math fans. X to the fifth y squared plus d by dx of x cubed y to the fourth equals d by dx of negative 20. All right, so as you can see here, we're going to be using the product rule because you got two variables multiplied. So let's start out here. It's the first times derivative of the second. So again, I'm going to kind of show some steps here. The derivative of y squared is just going to be d by dy. So again, I'm showing some steps here, times dy dx. So it's the first times derivative of the second plus the second times the derivative of the first. All right, and then I'm going to do the next one. It's the first times derivative of the second. So d by dy of y to the fourth dy dx. Okay, because you need, this is important, you have to have this, right? It's the two things here, right? The derivative of y and the dy dx. All right, so it's the first times derivative of the second plus the second, which is y to the fourth, times the derivative of the first equals d by dx of negative 20. All right, so a lot of stuff here. Let me just erase this little arrow here. Okay, and so now let's do that. It's x to the fifth. What's the derivative with respect to y? Well, times 2y. dy dx. Plus y squared. Derivative of x is 5x to the fourth plus x cubed. Derivative of y with respect to y is times 4y cubed dy dx plus y to the fourth times 3x squared is equal to derivative of constant, of course, is 0. So let's simplify this a little bit now. We have 2x to the fifth y dy dx plus 5x to the fourth y squared plus 4x cubed y cubed dy dx plus 3x squared y to the fourth equals 0. Okay, so I'm going to collect the dy dx is on one side, and I'm going to kind of factor out in one shot here. So 2x to the fifth y plus 4x cubed y cubed, and the other guys are moving over, so it's negative 5x to the fourth y squared minus 3x squared y to the fourth. Alright, so let's keep going. Divide both sides by that 2x to the fifth y plus 4x cubed y cubed. So 2x to the fifth y plus 4x cubed y cubed. And so I get dy dx. Now, I can simplify this a little bit. You guys agree that I can take a y out of here, and I can also take an x squared, right? Because all terms have a y and all terms have an x squared. So I can factor that out of there, and I wind up getting negative 5x squared minus 3y cubed all over 2x cubed plus 4xy squared. That's it. That's my answer. That's as simplified as possible. It looks nasty, and this is the deal, math fans, is you can have both x and y in your final answer. So x and y are allowed in the final answer. Okay? That's pretty sweet. Pretty sweet. All right, I want to do one more example with you guys, just finding the equation of the tangent line here. This is actually pretty mellow, so here it is. Find the lines that are tangent and normal to the curve 2x squared y minus 3x squared plus y cubed equals negative 3. Again, it's brutal looking, but using implicit differentiation makes it so much nicer. And I want you guys to find the lines at 2, 1. All right, so let's do it. D by dx of that gives you, again, we're using our product rules. So, and keep that 2 with the x squared. I mean, don't try and break that up and do, like, pull that out. It's just so much easier when you do 2x squared as your first term and y as your second term. So we're going to do the first times the derivative of the second. So the derivative of y is just 1 dy dx, right? So the first times derivative of the second plus the second times derivative of the first. That's just times 4x. And then the next one is really easy. That's just minus 6x. And the next one is pretty easy. Remember, it's derivative with respect to y, so it's plus 3y squared, but don't forget your dy dx. That's huge. And then equals 0 because it's a constant. Okay, so let's put this all together. 2x squared dy dx plus 4xy minus 6x plus 3y squared dy dx. And then I'm going to move, that equals 0. And then I'm going to group all these guys together, so I get dy dx times 2x squared plus 3y squared, and I'm going to move these other guys over, so I'm going to get 6x minus 4xy. Okay, and then divide both sides by 2x squared plus 3y squared, and so I get dy dx is equal to 6x minus 4xy over 2x squared plus 3y squared. And you can't really simplify that, so that's your derivative, the equation for the slope of the tangent. Now, of course, I asked you to find it at 2, 1. It's nice I gave you the x and y coordinate, because if I just gave you x, you'd have to solve for y, which again is really brutal, and you guys would not be happy. Okay, so I'm just going to find, of course, the slope, right? That's really what that is over there, slope of the tangent. And I plug it in, I get 6 times 2 minus 4 times 2 times 1 over 2 times 2 squared plus 3 times 1 squared. So my slope comes out to be negative, or 12 minus 8 over 8 plus 3, which is 4/11. All right, so we're good to go. Of course, we're going to put it in point slope form. So the tangent is going to be y minus 1 equals 4/11 times x minus 2. And the normal, and I asked you for the normal equation. Be careful, I just asked you for the normal slope. Make sure you just give me the slope and not, you're just going to give me, negative 11/4. Just watch for that. Don't give too much information, but make sure you give the right information. So y minus 1 equals negative 11/4 times x minus 2. All right. So again, these are really complicated ones. You could actually do implicit differentiation on any type of problem. It doesn't really matter. And in fact, if you think about it, if you have like y equals 2x squared, and I did implicit differentiation, just check this out, right? What is the derivative of y? Oh, isn't it 1 times dy dx is equal to 4x? Oh, look at that. dy dx equals 4x. That's exactly how we solved the problems before when you have y equals 2x squared. dy dx equals 4x. So we're kind of doing implicit differentiation normally, but now we're expanding it to much more complicated problems. All right. Anyway, that's it, math fans. I hope you guys learned a little bit here, and we're going to get into some more difficult ones for the next day where we actually do the second derivative. But for now, it's just all first derivative. All right. Adios. Goodbye.